here. Okay, perfect. So guys, yeah. Oh, Kimberly, you're here. Thank you, Kimberly. All right, thank you. All right, so we can, I guess we can start section 2.3. Yeah, Carolina, I just said actually I didn't grade the homework 5 yet. Okay, so I should I'm gonna grade it this week hopefully. All right. Yeah. So this is section 2.3. So guys, in section 2.2, we learned how to graph parabolas, right? Quadratic functions. So in this section 2.3, we're gonna see how to graph polynomial functions in general. All right. So this is about polynomial functions and their graphs. Okay. So let me first start with definition of a polynomial. I mean, you should think of a polynomial as a combination of powers of x. So whenever I have like a powers of x, just powers of x, then that would be a polynomial. So a polynomial functions are functions of the form. So polynomial functions are functions of the form. So we're gonna have just powers of x of the form. So f of x. So it would be x to the power n. So here power n is it's actually a whole number, positive whole number. And so x to the n, x to the power n, and in front of x to the power n, there's a some number. So let's call this number in front of x to the n a subscript n. Okay, a subscript n times x to the power n, and then after x to the power n, we have x to the power n minus 1. Okay, so for example, if n is 5, then n minus 1 would be 4. Okay, so that's x power n minus n. In front of x power n minus 1, there is a number, and we know the such number a subscript n minus 1, right? Plus etc. Right, and then at the end, we're gonna have, of course, x power 1. So here it's x power 1, and in front of x power 1 we have a subscript 1. Okay, and then plus, and then there is a constant at the end here, plus a subscript 0. Right. So the a subscript n minus 1, etc. a subscript n minus 2. So that's so a. So here a, where a subscript I. Okay, the I could be n or n minus 1, etc. So this a subscript I is just a real number. Okay. And of course, the n, as I said, the n must be positive. Okay, positive whole number. Okay. So actually, this n, this power n, has a name. So the n here, again, n here is the highest power of x. So this n is, that's the highest power of x. Okay, So this highest power of x has a name. It's called actually the degree of the polynomial. So n is called the degree of the polynomial. The degree of the polynomial f of x. All right. So this highest power of x is called actually the degree of the polynomial, and this first coefficient here, this a index n, this one here, the coefficient of x to the n is called the leading coefficient. So the a index n, or a subscript n. So a subscript n, this is called the leading coefficient. Okay. So for example, so let's have some couple of examples here. Examples. So let's say f of x is equal to negative 2x power 6 plus x power 5 minus 3x fourth plus, let's say, x squared minus 2x plus 4. Right? So you see here, guys, again, we have powers of x. So when you have just powers of x, then it's called polynomial. So this is a polynomial. So it's just powers of x. So the f of x is a polynomial. So f of x is a polynomial. Okay. Because we have just powers of x. Powers of x. Powers of x. Now, so what will be n, the degree of this polynomial f of x? So what will be the highest power of x here? Of course, well, the highest power of x would be 6, right? That's the 6 here. That's what I call n. That's the degree. So the 6, that's the degree of the polynomial. That's the highest power of x. So n. So n is actually equal to 6. That's the degree of the polynomial. Now, what will be the leading coefficient? What will be the coefficient in front of x to the power 6? Well, in front of x power 6, we have, of course, a negative 2. So this number here, negative 2, that's what I call the leading coefficient, right? That's my a, that's my a index n, or subscript n. So that's my n, my a subscript n, right? A subscript n. So a subscript n is equal to negative 2. That's the leading coefficient. Okay, so again, this leading coefficient is just the number in front of the highest power of x, right? Okay, let's have one more example. Another example. So let's say f of x is equal to 7 x power 4 minus 3x cubed plus 2x minus 4, right? So, of course, here, the highest power of x, the degree of f of x would be 4, right? That's the exactly, Carly. Yeah, so it's so n. So here, my n, the degree of the polynomial is 4. Okay, again, it's just the highest power of x. Now, in front of x to the 4, x power 4, so we have 7, and so 7 would be the leading coefficient. So the 7 here, that's what I call the leading coefficient. okay? So of course, this f of x is a polynomial. So f of x here, of course, this f of x is a polynomial. Okay, so again, guys, all you have to keep in mind is that the highest power of x is called the degree, and the number in front of the highest power of x is called the leading coefficient, right? Now, just be careful, the powers of x, they must be positive whole numbers. So if you have something like f of x equals to, let's say, x to the power, let's say 7 over 3 minus, let's say 2x squared, for example, plus 1, or plus x minus 4, right? So here we have this power x, this power 7 over 3, and of course 7 over 3 is a fraction, right? It's not a whole number. So in this case, this f of x is not a polynomial. So this is here, that's a fraction. So the powers of x, they must be whole numbers. Okay, they cannot be fractions. So if you have a fraction as a power, then that's not a polynomial. So this f of x is not a polynomial. Okay, so the reason is because there is some power of x which is a fraction. Okay, so because there is a power of x, which is a fraction. Okay, so powers of x, they must be all of them. They must be whole numbers. Okay. Another example, which is not a polynomial, if you have a power which is negative, so it must be positive. Powers of x, they must be positive. All right. So example 4. So let's say f of x is equal to minus 4x power 5 minus x to the negative 3, all right, plus x minus 1, right? So here you have a negative power, x to the negative 3, okay? So this is negative. Okay, so if you have a negative power, then your function f is not, it's not a polynomial. All right, then f of x is not a polynomial. Okay, so no fractions, no negative numbers. Okay, so f of x is not a polynomial because there is a power of x which is negative. There is a negative power of x. Okay. So if you have a fraction or negative power, then your function is not a polynomial. Okay, that's really important. All right. Any question, guys? All right. So here's a small exercise, an easy exercise. So you have to determine whether the function f is a polynomial, and you have to find the degree and the leading coefficient. All right. So here's an exercise. Okay, so you have to determine whether f of x is a polynomial or not. Whether f of x is a polynomial. Okay, and if it's a polynomial, if f of x is a polynomial, then please find the degree and the leading coefficient. Okay, so if f of x is a polynomial, find the degree n, and the leading coefficient. Right? So here's my functions. 1, 2, 3, 4, 5, and then 6. Okay, so let's say first f of x is -4, x to the power 5 minus x4 plus x cubed plus 2. All right, then f of x is, let's say here, -2, x cubed minus x to the power 7. All right, plus 2x minus 1. Next, f of x, let's say, is x squared minus x to the power 5 over 6, right, plus 2. Next, f of x is -2x cubed minus x to the power -4 plus 3, right? Next, f of x is actually x to the power 8 minus 10 x to the power 9 plus 1. And last one here, f of x, x to the power -1 plus x minus 1. So Irada, first page of, yeah, sure, okay. First page. You mean probably the definition of the polynomial? Right here? Thank you. Okay, thank you, Irada. Okay, guys, so you have a couple of minutes to determine whether f is a polynomial or not. And if it's a polynomial, then please find the leading coefficient and the degree, right?
Professor,
Yes.
you said that if the result is negative, it's not a polynomial.
Yes.
Okay.
Yeah, absolutely, yeah.
Thank you.
right. Okay, guys, I guess you're done. So for the first function f, you know, so you check the powers. All the powers of x are, positive, positive whole numbers, right? So then your f of x is a polynomial. So this is a polynomial. So this one here, it's a polynomial. Right? Now, what will be the degree of the polynomial f? Okay, so again, a degree, that's the highest power of x. So of course here, the highest power of x would be 5. So my degree is 5. So here's my degree. Okay, so here's my degree. And now what will be the leading coefficient? So remember, guys, leading coefficient, that's the number in front of the highest power of x. So of course, highest power of x is 5, and the leading coefficient then would be the -4. So this -4 here, that's my leading coefficient. Right? Now, next, well, again, all the powers of x here are positive whole numbers. So then this f of x is actually a polynomial. Now, what will be the highest power of x? So just be careful, guys. The highest power of x doesn't have to be, yes, absolutely, Crystal. So yeah, so the highest power of x, it doesn't have to be like in the first power. It could be the second power, like in this example, as Crystal said. So the degree here would be 5. It would be 7. Sorry. So here's my degree, and the leading coefficient is of course the number in front of x to the power 7. So that's the -1 here. So that's my leading coefficient. Right. Next is f of x a polynomial. Well, so here we have a fraction 5 over 6, right? You have a power which is a fraction. So then f of x is not a polynomial. So this is here for number 3. This is not. It's not a polynomial. Okay. So here, not a polynomial. Right. Next, number 4. So we have minus 2x cubed. That's good. Minus x to the power -4. So we do have a negative power. Then that's not a polynomial. So this is not a polynomial. Okay. Next, we have x power 8 minus 10 x power 9 plus 1. So all the powers of x are positive whole numbers. That's good. Now, what will be the degree? Again, here the degree is not necessarily the first power of x. The degree is the highest, right? Yeah, Crystal, absolutely. So it would be 9 here. So the degree is actually 9. And of course, the -10 would be the leading coefficient. So this -10 here, that's my leading coefficient. Okay. Again, this f of x is a polynomial. All right. Now, next, I guess probably I erased something here. There should be -1 here, I think. Anyway, so for the last one, we have x to the power -1 plus x minus 1. Well, here we do have a negative power. So it's not, f of x is not, this is not a polynomial because of this negative power. Here, it's because of this fraction, the 5 over 6. And here it's because of this x to the -4, right?
Professor,
So, yes.
so basically any fraction or any negative numbers is not a polynomial.
Yeah, yeah. Whenever you have a power which is a fraction or a negative number, then it's not a polynomial. Yeah, absolutely, yeah. Okay, so now what about the known, well-known examples of polynomials? So, well, we do know actually a couple of examples of polynomials. So, for example, quadratic functions are polynomials, right? Quadratic function, the highest power of x would be 2, so your degree would be equal to 2, right? So, so some well-known polynomials. Okay, so first we have quadratic functions, right? Quadratic functions. And we know how to graph quadratic functions, right? That's section 2.2, quadratic functions. Right? So again, quadratic function, for example, f of x equals to -4, let's say, x squared minus x plus 1, right? So in the quadratic function, the highest power would be 2, so that would be the degree. So the degree here, so n, the degree is equal to 2, right? And my leading coefficient, of course, that will be the number in front of x squared, which is -4. So my leading coefficient, so a index a subscript n, my leading coefficient is -4. Okay. Anyway, so quadratic functions are examples of polynomials, right? With degree equal to 2. Now, of course, the power of x, the degree n could be equal to 1, right? So if you have number 2, second well-known in polynomials, it would be the so if you have like f of x, you know, let's say 3x minus 4. Okay, so here, what would be the highest power of x? So when you have x, guys, of course, if you have x, that will be like x power 1, right? So if you have just x, then the degree n is equal to 1, right? That's the highest power of x. It's 1, all right? And of course, your leading coefficient, a subscript n, is equal, so in this example, that will be 3. Okay, that would be my leading coefficient, right? So whenever I have just power x, like ax plus b, then such functions are called actually linear functions. So such f of x is called linear function, right? So it's linear function. So what do I mean by linear function? Well, that's a polynomial where the degree n is equal to 1. When the highest power of x is 1, then it's called the linear function. So this is so when the degree n is equal to 1. Okay, and I mean, we are supposed to know actually how to graph linear functions. Linear functions, again, they are functions of the form ax plus b, right? Where the highest power of x is 1. So linear functions, the graph of linear functions are just straight lines, okay? Graphs of quadratic functions are parabolas. So here, for quadratic functions, the graph is a parabola, right? Now, when you have a linear function, then the graph is just a straight line. Is a straight line. Okay. Well, there's another very simple example of a polynomial is when you have just when the highest power of x is just 0. So that would be my third well-known example. So for example, if you have f of x equals to, let's say, -4. Okay. So here, when I write f of x is equal to -4, it means that you know, for each input x, the output is always -4. Okay, so the output is always -4. Is always -4. So for example, how do we graph such function f? How do we graph f of x equal to -4? You know, so you have your, let's say here's somewhere here, you have -4. So let's say this is -4, right? And here's my input x. My x here, this is my y, of course. And so what I'm saying, f of x is equal to -4. So what I'm saying is that the output is always -4. So like this is my, let's say this is -5. So the image of, or the output of -5 is -4. Here is the same, -4. Here is the same, -4. No, -4, -4. So it's just a horizontal line, right? That's a horizontal line. So when you have f of x equal to a number, okay, then the graph would be a horizontal line, of course. And such a function is called a constant function, right? Constant because it doesn't change. The output is always the same. It doesn't change, okay? So now, okay, so let me just write down here. So such function f is called a constant. So such f of x is called a constant function. A constant function means that the output is fixed. The output is always the same. Now, so why this constant function, why this -4 is a polynomial? Because I mean, you may say, well, we don't see any power of x, right? Well, the thing is, remember guys, we said when you have 1, if you have 1, then actually 1 is equal to x to the power 0, right? I mean, any non-zero number power 0 is equal to 1. So this -4, you can write this -4 like -4 times 1, right? And so that would be -4 times, so that's equal to, right? So that's equal, so your f of x is equal to -4 times, because we said 1 is x to the power 0, so that's -4 times x to the power 0. So that's x to the power 0. So actually the degree, the highest power of x here, if you have just a constant, the highest power of x would be just 0. So my degree n in this case would be 0. So that's my n. The highest power of x is 0. And of course, the leading coefficient would be this -4. This one here. That's my leading coefficient. Okay, so what I'm saying, guys, is that when we have a constant function, again, what I mean by constant function is just we have just a number, f of x is equal to a number, then it's actually a polynomial, and the degree n is just 0, right? So, so for constant functions, the degree n is 0. So for constant functions, the degree n is 0. All right. Okay, so and again, so we know how to graph parabolas. I mean, we know how to graph quadratic functions. When you have a constant, then that would be just a horizontal line. And if you have a linear function, so again, linear function means that the degree n is 1, then the graph would be just a straight line. But anyway, so today we're gonna learn how to graph polynomials in general, right? So first thing we're gonna do is we're gonna study the behavior at infinity of polynomial functions. So the goal today, we're gonna try to graph polynomial functions So the goal is to graph any polynomial function. So we know how to graph parabolas, quadratic functions. I mean, if you have a linear function, that will be just a line. Now, so now let's do it for any polynomial, okay? So first, we're gonna start with the behavior at infinity. So first thing we're gonna do, so let's start with the behavior at infinity. Okay, so let's take examples and let's see what happens at infinity. So my first example, I'm gonna just start with the quadratic function. So I'm gonna take like, let's say, so example one, let's just take f of x equal to x squared. So example one, I'm gonna take f of x equals to x squared. So of course, x squared, that's a quadratic function, right? In particular, it's a polynomial. So what will be the degree here? N. So n, the highest power of x, of course, is 2. So n, the degree, is equal to 2, right? That's the highest power of x. And of course, here 2 is, that's even, right? Which is even. Right? Now, what about the leading coefficient? Well, that's the number in front of x squared. And of course, here, you can put 1 in front of x squared. So this is like 1 times x squared. So my leading coefficient would be 1, right? So, so the a subscript n, the leading coefficient, is equal to 1, okay? And that's positive. It's positive. Anyway, so the graph of x squared, of course, it would be a parabola. The graph of x squared is a parabola, and it's gonna look like. So we are interested in the behavior at infinity, right? So we are interested in, you know, the graph, the shape of the graph, what happens to the graph at infinity. So, so here, this is positive infinity. Here's supposed to be negative infinity, right? Here's my positive infinity, and this is here my negative infinity. Of course, this is supposed to be the x-axis, my x-axis, and this is supposed to be my y-axis. Right? Anyway, so the graph of x squared, we know how to graph parabolas. So the graph of x squared would be like, looks like something like this here. All right, so this is, let's say, this is f of x equal to x squared. Right? Now, as I said, we are interested in the behavior at infinity. So what happens at infinity? So when your x approaches infinity, so you're on the x-axis, right? You are on the x-axis, and your x approaches infinity. So let's say your x is here, right? Approaches infinity. What happens to the value of the function f? Well, you see here, the value of the function f is actually, it approaches infinity, right? So when your x is approaching positive infinity, right? The output is also approaching positive infinity, right? So, so let me just write it down. So when x approaches positive infinity, so this arrow here means approaches or goes to. Okay, so when your x approaches positive infinity, y, the output, okay, here's my y, right? This is my output y here, right here. My y approaches positive infinity. So my y approaches positive infinity. Okay. Now, what happens when x approaches negative infinity? So my x now is at negative infinity. Let's say here, right? Here's my x here, right? So the image, the output, is going to approach, of course, the same thing, positive infinity, right? So when x goes to positive infinity, so when x goes to positive infinity, then y, negative infinity. So when x goes to negative infinity, right? So here's my negative infinity, right? The image, the output, the y approaches positive infinity. Then y approaches positive infinity, right? So you see, so this is for x squared, right? X squared is a polynomial, the degree is 2. The leading coefficient is 1, which is positive, right? And so you see what happens when x goes to positive infinity or negative infinity, right? In both cases, the output y would go to positive infinity. And this is actually a general fact. So whenever the degree is even, like here, the highest power of x is even, right? So whenever the degree is even and the leading coefficient is positive, all right, then that's actually what we get at infinity. So this is in general. So in general, if you have a polynomial, so f of x, if f of x is a polynomial, okay, with even degree, with even degree n, right, and positive leading coefficient, then at infinity coefficient, okay, then so when you graph the function f, the polynomial f, then at infinity, so this is my positive infinity, here's my negative infinity, here's my positive infinity, right? Negative infinity. Then actually at positive infinity, when x goes to positive infinity, y goes to positive infinity. So which means that here, your graph at infinity, positive infinity, the graph looks like this here, this part here, all right? And at negative infinity, when x goes to negative infinity, your y also goes to positive infinity. So here at negative infinity, the graph is going to look like this here. All right. So what I'm saying, guys, is whenever you have a polynomial with even degree and a positive leading coefficient, then your graph looks like this here. All right. And here at infinity. Okay. So so this is when the degree is even and leading coefficient is positive. So now what about even degree and negative leading coefficient? Okay, so for example, so that will be our example number 2. Example number 2. Let's say now f of x is equal to negative x squared. Right? Of course, this is a quadratic function. It's in particular, it's a polynomial. The degree n is 2, is even. So n, the degree is 2, which is even, of course, right? And the leading coefficient is negative. My a subscript n is negative 1. So a subscript n, the leading coefficient is negative 1, which is negative, of course, is negative. Right? So if you graph negative x squared, remember negative x squared because the coefficient of x squared is -1, it's negative. So we're going to have a parabola which opens downward, right? So we're going to have, oops. So then the graph of f of x negative x squared. So here's my positive infinity, negative infinity, positive, negative, and then negative x squared would be like, so the vertex is at 0, 0, right? And then we're gonna have something like this here. So it's a parabola which opened down here. All right, so this is my f of x equals to negative x squared. All right, so now let's see what happens when x goes to positive infinity. So my x now is here. So my x is approaching positive infinity, right? Then the output, the image, see here the image, y, the output y is going to approach now negative infinity, right? So when x, again, so when x approaches, it's close to positive infinity. So your x is here, right here. It's close to positive infinity. The output y, you see your output, this is y. This is supposed to be y, right? Your output y is close to negative infinity. So when x approach positive, then the output y approaches negative. Okay, now what happens at negative infinity when your x is at negative infinity, right? My x is approaching negative infinity right here, right? So then the image, the output, would approach negative infinity too, right? So when x approaches negative infinity, then y is gonna approach negative infinity too. Right? And so again, this is actually a general fact. Whenever we have even degree and the leading coefficient is negative, okay, so then in general, okay, so if the degree n is even and the leading coefficient is negative, right? Is negative. Okay, then your graph should look like, okay, so here's, let's say, your graph of f of x. Okay, this is positive, negative infinity. This is positive infinity. Here's my negative infinity. Then the graph of f of x should look like when you are close to infinity. So when you are close to positive infinity, the output should be close to negative infinity. So here should be your graph of f of x. And the same when x is approach negative infinity, the image is going to approach the output y is going to approach negative infinity too, right? So that will be the graph of your function f when your x is close to infinity, either positive or negative, right? Okay, so this is for, of course, guys, please interrupt me if you have any question, right? Now, so this is when the degree is even, right? So now let's see what happens when the degree is odd. Okay, so let's take an example with the degree odd. So that will be our example number 3. Example 3. So let's just take x cubed, right? So let's take f of x equals to x cubed. So the degree n is the highest power of x, of course, would be 3. My n is, of course, 3, which is, of course, odd. 3 is odd. Now, the leading coefficient, so here it's supposed to be 1 times x cubed. So then the leading coefficient, of course, would be 1. It's positive. So my a subscript n, okay, that's my leading coefficient. So my leading coefficient is 1, and of course is positive. 1 is positive, of course. Now, so what would the graph of x cubed look like? Well, so if you try to graph x cubed, then so again, we are interested in the behavior at infinity, right? So this is plus infinity, negative infinity, positive infinity here, negative infinity. But anyway, if you graph x cubed, so then the graph would is going to be like, so the graph of x cubed is going to be like this, right? So this is f of x equals to x cubed. Anyway, so let's see what happens when x approaches or goes to positive infinity or negative infinity. So your x goes to positive infinity. So here's my x, it's going to positive infinity, right? Then the output, you see the output y here. So the output y is gonna approach positive infinity. Okay, so when x goes to positive infinity, then y, the output goes to positive infinity, right? Now, what happens when x goes to negative infinity? So here's my negative infinity, here's my x going to negative infinity. So then the image, the corresponding output, is gonna go, of course, to negative infinity. So when x goes to negative infinity, then y goes to negative infinity, right? And again, this is actually a general fact. So whenever you have a polynomial with odd degree and positive leading coefficient, right? Then that's actually what happens at infinity. So again, this is in general. So in general, so if you have f of x, if f of x has an odd degree with positive leading coefficient, okay, then the graph of f of x is gonna look like at infinity. So then the graph of f of x, so when x goes to positive infinity, y is gonna go to positive infinity, right? And when y goes to, so this is, of course, this is positive infinity here, positive infinity, negative infinity, negative infinity. So when your y goes to negative infinity, then your x, when your x goes to negative infinity, then your y is going to go to negative infinity too. So here's my y. Okay. Now, last case is when you have an odd degree and negative leading coefficient. So this is, so example number 4. Example 4 is when you have, let's say, minus x cubed, f of x minus x cubed. So the degree is odd. And of course, the leading coefficient is negative. -1, so it's negative. So if you graph actually a negative x cubed, so the graph of x cubed would be like negative x cubed. And again, we are interested in the behavior at infinity. So here's my positive infinity, negative infinity, positive, negative. So negative x cubed would be like something like this here. Okay, so this is my f of x equals to negative x cubed. But anyway, so you see, guys, here what happened. So at positive infinity, here's your y is going to go to negative infinity. And at negative infinity, your y is going to go at positive infinity, right? So, so summary, guys. So this is so here's so a summary. So you see this behavior at infinity, it depends on the degree and the sign of the leading coefficient, right? So so we have like let's say, so we have the following table. So if you have like so we have like let's say we're gonna have the following table. So here, this is my degree n. Degree n is here is even. Here my degree n is odd. Right. Here my leading coefficient is positive. Right. And here last the last last one here, leading coefficient. The last row here, leading coefficient is negative. Okay. Anyway, so what we are saying, guys, is that if you want to graph, here's your f of x. F of x here is supposed to be polynomial, is a polynomial, right? Anyway, so if you want to graph your polynomial, so we have these 4 cases, right? So we are saying, so the first case is when the degree is even and leading coefficient is positive, like x squared, positive x squared. Then we said at infinity, so at positive infinity, when x approaches positive infinity, y is going to approach positive infinity, and when x approaches negative infinity, then y is going to also approach positive infinity. So this would be the graph of f of x in the neighborhood of infinity, right? Now, when the degree is even and leading coefficient is negative, like minus x squared, so that would be a parabola minus x squared. It's a parabola which opens downward, right? So then at infinity, we're going to have something like this here, right? Now, when the degree is odd and the leading coefficient is positive, like positive x cubed, so at infinity, positive infinity, you're going to have like something like this here. X goes positive infinity, then y goes positive infinity. And here, when x goes to negative infinity, then the output would go to negative infinity. Now, last case, when the degree is odd and leading coefficient is negative, like this, like this negative x cubed. So we see here negative x cubed at positive infinity. So at positive infinity, here's your graph at positive infinity, and here's your graph at negative infinity, right? So it's gonna be the same for any polynomial of odd degree and negative leading coefficient. So at positive infinity, we're gonna have something like this here, okay? And at negative infinity, we're gonna have something like this here. Your x goes to negative infinity, then your y is gonna go to positive infinity, right? So why we are doing this? Because again, so what we are saying here is that if you have any polynomial f of x, okay, and so you want to know what happens or where's your graph of f in the neighborhood when you are close to infinity, then actually we can use this table to determine exactly the behavior of the graph at infinity, right? So we're gonna use this later, of course, to graph our polynomials, right? Is there any question, guys? Okay, no questions. Then, okay, so yes.
Just want to copy it, please.
Oh, okay, sure. Um, Okay, so that's for the behavior and infinity. Next thing we need to graph polynomials is, of course, the x-intercepts. Okay, so of course, if you have a polynomial and you want to find, remember the x-intercepts, we have to solve f of x equal to 0, right? I mean, if you have a quadratic function, yes. So I mean, you can use a quadratic formula to solve f of x equal to 0. Now the question is, what about polynomials with of a higher degree, like if you have a cube or x to the fourth? So then, of course, then we have to factor. So yeah, so next, guys, so that's for the behavior at infinity. So next, as I said, so we're gonna study the zeros or the x-intercepts. So x-intercepts, or so we call x-intercepts zeros or roots, okay, of polynomials. And so zeros or roots, they mean the same thing. It's just solutions of f of x equal to 0. So so let me just remind you. So that's again, this is just the definition of x-intercept. So this is so so the zeros or the roots or I mean the x-intercepts, okay, of f of x, okay, are just the solutions of f of x equal to 0. So that's again, that's where the graph intersect the x-axis, right? So our solutions of f of x equals to 0. Okay, again, that's where that's the intersection of the graph with the x-axis, right? Intersection of the graph with the x-axis. Right. Now, so now we're gonna distinguish between actually the different kinds of roots or zeros. So, well, so there is a notion of what we call the multiplicity of a root or a zero or x-intercept. So, so next, so this is definition here. Definition. So the multiplicity of a root or a zero or x-intercept is just the number of times the zero or the root is a solution of f of x equal to 0. So the multiplicity of a root or a 0, okay, is the number of times the root is a solution of f of x equal to 0. So what do I mean by the number of times the solution is the root is a solution of f of x equal to 0? So it's a solution of f of x equal to 0. So here's an example of x equals 0. So examples. Examples. Let's say you have example. So let's say f of x is equal to let's say just x squared minus 2x plus 1, right? So let's find the roots or the x-intercept or the zeros of f of x. So let's find the roots. Or zeros of f of x. So we have to solve, f of x equal to 0, right? So we have to solve f of x equal to 0. Right, so we want to solve x squared minus 2x plus 1 equal to 0, right? Of course, we can use a quadratic formula, or we can try to factor, right? So if you want to factor, so how do you factor this x squared minus 2x plus 1? So we're going to have, well, you can, if you use the quadratic formula, of course. Okay, so let's just use the quadratic formula first. Use quadratic formula. Just be careful with the quadratic formula, guys. I think some of you probably had the wrong formula. So because when you in the test, you at some point you had to find the vertex or the x intercepts of the quadratic function, right? But yeah, but I think some of you got the wrong formula. So for the quadratic formula, it should be x equal to minus b plus or minus square root of b squared, right, minus 4ac over 2a, right, over 2a here, 2a. Anyway, so so here, of course, your x is minus b, so it's minus -2, plus or minus square root of b squared. It's 4 minus 4 times a, that's 1, times c, that's 1. So over 2 times 1, of course, right? So so that's x minus, so minus -2, of course, that's positive 4, plus or minus, so this is a 0, square root of 0 over 2, so it's 4 plus or minus 0 over 2, right? Anyway, so it's just, sorry, it's not 4, I said 4 here, it's positive 2 here. So this is positive 2, so it is positive 2. All right, so it's just 2 over 2, right? So my x is equal to 2 over 2 is equal to 1, right? So you see here, guys, I mean, because of the plus or minus, you're supposed to have, two possible solutions here because of plus or minus, right? Because, you have the quadratic function, right? You have a square. So when you have a square, you are supposed to have, two solutions. If you have x cubed, then you're supposed to have 3 solutions, etc., right? So here I'm supposed to have 2 solutions, right? This is because of this plus or minus. I'm supposed to have two solutions, 2 possible solutions, but I got just one solution, right? I got one solution here. So this one here, x is equal to 1, this is actually 2 times, this is 2 times solution of f of x equal to 0, because, I am supposed to have two solutions, all right? But I end up with only one solution. So this one solution, which is x equal to 1, is actually 2 times solution of f of x equal to 0. So this is 2 times solution of f of x equal to 0. And that's because, I mean, if you want to factor x squared minus 2x plus 1, if you factor x squared minus 2x plus 1, right, then of course you're gonna have actually x minus 1, right, times x minus 1 equal to 0, right? So you see here, it's because so we have x minus 1 times x minus 1. So again, that's why 1 is 2 times a solution of f of x equal to 0. So, and so the multiplicity of the solution 1 here is 2. Okay, so the multiplicity of the solution 1 is, so the multiplicity of the solution x is equal to 1 is 2. Okay, because you see here x minus 1 times x minus 1, right? So 1 is 2 times solution of f of x equal to 0, right? So that's the multiplicity of 1. So 2 is the multiplicity of 1, right? Of course, if you have, let's take another example. So this is for x squared minus 2x plus 1. If you take example number 2, another example, let's say f of x equals to x squared minus 3x plus 2, right? So let's find the roots. Find the roots and their multiplicities. Right? So again, the roots is just x-intercept, so we have to solve f of x equal to 0. Solve f of x equal to 0. And so we have to solve x squared minus 3x plus 2 equal to 0. Again, either use quadratic formula or you can factor. So if you decide to factor, I mean, here solutions, solutions, if you use a quadratic formula, solutions are, x, if you use a quadratic formula, then the solutions are, x equal to 1 and x equal to 3. X equal to 2. Okay. So I mean, if you factor this x squared minus 3x plus 2, so it's going to be x minus the first solution. So it's x minus 1 times x minus the second solution, which is x minus 2 equal to 0. Okay, so you see, guys, when you factor, it's always you have, x minus the solution. So it's x minus first solution, right, times, and then you have x minus the second solution. So x minus the second solution. Again, I got the solution. The solutions here are 1 and 2 because of the quadratic formula, right? You can just use the quadratic formula and you get 1 and 2, right? Solutions. So this is my second solution. So this is equal to 0. So when you factor, guys, again, you see how I factored this x squared minus 3x plus 2. So it's always like x minus. So again, it's a square. So we are supposed to have two solutions. Supposed to have two solutions, right? And so when you factor, is the factorization is supposed to be of the form x minus the first solution times x minus the second solution, right? Anyway, so I have, so the roots are 1 and 2, right? That's the solutions. The roots are, so here's the answer. So the roots are 1 and 2. Now, what about the multiplicity? Well, multiplicity of 1, here 1, you see here 1 is just one time solution, right? It's just x minus 1. There's just one x minus 1, right? So this is one time solution. So one time. This is one time solution, right? The same for 2. It's x minus 2. This is just one time, right? This is just one time, one x minus 2. So this is a one time solution. Right? So the multiplicity of 1 is, it's because one time solution. So then the multiplicity of 1 is 1. So multiplicity of 1 is 1. Multiplicity of 1 is 1. And the multiplicity of 2, it's just one time solution. So the multiplicity of 2 is also 1. It's just one time solution. Now, I mean, this is, this is when you have a quadratic function. So we can use the quadratic formula to solve f of x equal to 0. And now the question is, what about higher degrees? So for example, what about, so next example, example 3. Let's say f of x is equal x cubed plus, let's say 7x squared minus 4x minus 28. Okay, and the question is, of course, find the roots. Find the roots and their multiplicities. Okay. Okay, so first thing, guys, this is the degree here. The f of x, of course, is a polynomial. The degree is highest power of x is 3, right? So my degree here is 3. So it's not a quadratic, right? So we cannot. So if you want to find the roots, you need to solve. We need to solve f of x equal to 0, right? So we need to solve x cubed plus 7x squared minus 4x minus 28 equal to 0, right? So here there's a problem here. It's not the quadratic, so we cannot use quadratic formula, right? We cannot use quadratic formula because it's not it's power. I mean, it's a cube here, so we cannot use quadratic formula, right? Now, because of the cube, because the power, the degree is 3, then we expect to have 3 solutions, right? So we expect to have 3 solutions. Okay, so if the highest power, if the degree is 4, if the highest power of x is 4, then you expect 4 solutions, etc. Right? Anyway, so we expect to have 3 solutions. So we have to solve this x cubed, etc. equal to 0, and we said we cannot use quadratic formula. So if we cannot use quadratic formula, so how do we solve this x cubed plus etc.? Well, the idea, of course, is to factor, right? So we need to factor. So we need. So the idea is to factor, right? Right. So they have this x cubed plus 7x squared minus 4x minus 28, right? So how do you factor such a polynomial? First, you can try to, first step 1 is to find the common factor, right? So step 1, so you can ask yourself, is there a common factor? Is there a common factor, right? Well, the answer is, of course, I mean, if you check the, the terms here, I mean, there's no really a common factor. Okay, so here the answer is no. Okay, well, here there's an x, here's an x, here's an x, but here minus 28, there's no x there, right? So I mean, there's no real common factor here. So if there's no common factor, then we can try partial factoring. Okay, so what do I mean by partial factoring? Well, you can, so here's my x cubed plus 7x squared minus 4x minus 28 equal to 0. So instead of looking for a common factor for the four terms, so what can I do? What I can do here is I can take, for example, instead of the all terms, I can take, for example, the first two terms, right? If you just take the first two terms, right, then you can see there is, of course, there is a common factor here. So a common factor would be, here's an x cubed, here's an x squared. So a common factor would be x. Common factor, and I can do better than x actually. A common factor here would be x squared, right? Common factor is actually better than x, is actually x squared. Right? And here, if you take the last two terms, minus 4x minus 28, what would be a common factor in the second two terms here? Well, x is not the common factor because there's no x in 28, of course. But I mean, 4 and 28, a common factor. I mean, 28 is divisible by 4, right? I mean, 28 is 4 times 7. So a common factor would be, for example, would be 4, right? So here, a common factor is 4, right? So let's factor the first two terms. So we said the common factor is x squared. So I can pull out or factor out x squared. So here's my x squared here and here. So if you pull out x squared, so this is times, of course. So I mean, to get x cubed, you have to multiply this x squared by x, right? And then there is, of course, there's a plus here. So here's my plus. And you factor out this x squared. So then you are left with 7, right? So here's my 7, x plus 7, right? And then there is minus, and then we said the common factor between 4x and 28, that would be 4. So here's my 4 times. So of course, this is 4 here, right? You know, put out this 4 here, 4 here. So then you are left with x. All right. Then here the sign, be careful, guys, because here it's a minus. But I mean, if you factor 4 here, factor out 4, so then here it should be, you know, it should be a plus, because when you distribute the sign, I mean, minus times a plus, minus times a plus, that will be a minus, right? So that's why we have this plus in here, right? And then you factor out 4, then of course 28 is 4 times 7, so that would be x plus 7 here. That's equal to 0. So that's what I call partial factoring here. It's you just factor, you try to factor the first, let's say, two terms or the first three terms, etc. Okay, you don't factor the whole thing. You just factor the first, let's say, two terms and the last two terms, right? Then once you factor this, you do this partial factoring, then you can see now we have a common factor. We have this x plus 7, right? Here's my x plus 7, here's my x plus 7, right? So then I can, of course, I can factor out this x plus 7. All right, so now if you factor out x plus 7, x plus 7, then times, and then of course, if you pull out x plus 7, then you are left with x squared here. And then there is a minus, this minus here, this minus, so here's my minus, and you factor out x plus 7, then you are left with 4. So this is x squared minus 4, of course, equal to 0. All right. So you see, guys, I got this x plus 7 times x squared minus 4. Now this is, well, this is x plus 7. Now x squared minus 4 can we factor x squared minus 4?
Yeah.
Well, I mean, this is x squared minus 4. It's it's just a quadratic function, right? X squared minus 4. So you can try to use a quadratic formula, for example. So if you use a quadratic formula, if you solve x squared minus 4 equal to 0, you can use the quadratic formula, or you can just try to solve this x squared minus 4 equal to 0. You can say this is plus 4 here both sides, so that's x squared equal to 4, and then you apply square root. So then your x would be plus or minus square root of 4, which is plus or minus, so then your x is plus or minus 2, right? So if you solve x squared minus 4 equal to 0, we get two solutions, right? We get positive 2 and negative 2. So now, how do you factor this x squared minus 4? So that would be x minus my first solution. So it's x minus 2, right? That's my first solution, times, and then x minus my second solution. My second solution is negative 2, right? So it's x minus negative 2, right? Equal to 0. So what I'm saying, guys, is that this x squared minus 4, if you factor x squared minus 4, then you get x minus 2 times x plus 2, right? So this is x plus 7 times x minus 2 times x plus 2, right? Equal to 0. Okay. And so you see, guys, here we got, so what are the solutions here? Well, so x plus 7 times x minus 2 times x plus 2 is equal to 0. If you have a product, so remember, guys, if you have a product of numbers equal to 0, it means that one of the number is 0. So then your x plus 7 is 0. First number is 0, or the second number is 0, or the third one is 0, right? So then, of course, x plus 7 is 0, so then your x is negative 7, or your x is positive 2, or your x is negative 2.
Yeah.
Your x is negative 2, right? So anyway, so you see, guys, we got three solutions, right? Negative 7, positive 2, and negative 2. And that's what we expected, right? We expected, we said, because the power, it's x cubed, so the power, the degree is 3, right? We said we expect to have 3 solutions, right? Now, so then the roots, or the zeros, so the zeros, so the roots of f of x are, so of course, first solution is negative 7. So now, what's the multiplicity of negative 7? Well, you see, guys, here, remember, this is supposed to be, so this is x plus 7, so it's this one here, it's just one time, right? It's just one time solution, right? This is one time here, one time solution, right? So this x equal to negative 7 is of multiplicity 1, right? Now, next solution is positive 2, right? So x is equal to positive 2. This is, so x minus 2, it's 2, it's one time solution, right? So it's of multiplicity 1, and right, and then the last solution, x equal to negative 2. So x is equal to negative 2. So it's also one time. This is one time. Remember, you have always like x minus the solution, right? This is x minus the -7, right? This is x minus your 2, which is solution, and this x plus 2 is x minus -2, right? Anyway, so x is equal to -2 is also of multiplicity 1. All right. Any question, guys, about the multiplicity? So we have to factor. So the idea is, we have to, yes.
Turning
Yeah, go ahead.
the multiplicity.
Uh-huh.
So when you say like -7 is of multiplicity of 1, I don't
Multiplicity
get
1.
it.
Yeah.
Yeah. So I don't get it. I can read it, but I don't get it.
It's because when you factor, you
Yeah.
see when I factor it here, this factorization here, right?
Yeah.
I got x plus 7. X plus 7, this x plus 7, that's why I got -7 as a solution, right?
Yes.
So this x plus 7, it's just one time. It's just power 1 here. I mean, this is x plus 7 to the power 1, right?
Yes.
So if you had x plus 7 to the power 2,
Yeah.
then that would be multiplicity 2.
Yes. Okay.
Okay, so if you have x plus 7 power 3, then that would be multiplicity 3.
Okay.
Okay, so like here, my first example, you see this, my first example was this one here with the x squared. You see this x squared minus 2x plus 1. And we said if you factor, you're going to have x minus 1 times x minus 1, right?
Yes.
So that's like x minus 1 square. So it's the x equal to 1 here is of multiplicity 2 because it's, 2 times solution here.
Yeah.
Right? So, I mean, this multiplicity is just the power of your x minus the solution. Okay, so here my solution is 1. So I got x minus 1 to the power 2. So then the multiplicity of x equal to 1 is 2.
Yes.
Okay, it's just you check in your factorization, you check how many times you have x minus your solution, right?
Okay.
Okay.
Thank you.
So you're welcome. So okay, here's an exercise, guys. So you have to find the roots and the multiplicity of the roots. Okay, so exercise. So exercise. So find the roots. Again, the roots are just solutions of f of x equal to 0. So find the roots and their multiplicities. Okay, so number 1. So let's say f of x is x cubed plus 4x squared plus 4x. All right. Number 2. F of x, it's x squared, say plus 4x plus 4. Okay. 3. F of x is x cubed minus 4x squared minus x plus 4. All right. Number 4. F of x is x to the power 4, x fourth, minus 3x cubed plus 2x squared, right? Yeah, so probably, yeah. So please guys, find the roots and their multiplicities, okay? So remember, to find the roots, you have to solve f of x equal to 0. So first step is, so you have to, so step 1 is always, so solve, okay, solve f of x equal to 0, okay? And to find the multiplicities of the roots, so you need to factor, solve and factor f of x. So this is solve and, so we have to solve and factor f of x equal to 0. Okay. So you may ask why we are doing this. Why do we have to find the multiplicities of the roots? So we're gonna see, I guess, next time. If for example, if we have if the multiplicity of the root is even, all right, then actually the graph of f of x is gonna touch the x-axis, because the root is supposed to be x-intercept, right? So but then if the multiplicity is even, then the graph is going to touch the x-axis and turn around. So what I'm saying, so this is, we're going to see this next time, of course. So what we're going to see next time is that if the multiplicity is even, right? So you have a root, so we have x-intercept here, but then if the multiplicity is even, then the graph is going to touch the x-axis and turn around, okay? But then if the multiplicity is odd, okay, so again, you have a root, which means they have an x-intercept. You intersect your x-axis, but then if the multiplicity is odd, then the graph is going to just cross your x-axis. So that's why we are trying to find the multiplicity of these x-intercepts, or the multiplicities of these roots, okay? So it's going to help us, with graphing the polynomial f of x. Oh wow, we have just 1 minute. Yeah. Anyway, guys, probably I'm gonna stop here for today, and yeah. So I'm gonna come back to this factorization and roots and multiplicities, I guess, next time. All right. So I'm gonna do this exercise next time. Right. So let's stop here, guys, for today, and I will see you on Wednesday. Is there any question, guys? All right, so let's stop here, and I will see you next Wednesday.
Okay.
Take care. Thank you, everyone.
Bye.
Bye. Thank you. Take care.